name is Janvi Doshi and I'm here with some amazing science experiments. I'm from Bombay Teachers Training College and this is a part of Science Corner. These experiments I am performing to popularize Science Corner. So let's get started. The experiment that I'm going to perform today is about the color pattern that I see in different types of solutions. One of which the solution is going to be a sugar solution and the other is going to be a salt solution and the third one is obviously going to be the normal water. Now for this we need 3 glasses of normal water. I need some tablespoons of salt and some tablespoons of sugar. I am going to mix all of these into the respective glasses. I'm going to make sure that they are dissolved well. Here I'm taking powdered sugar so that it dissolves quickly. I'm going to mix them. I'm also going to mix this. We all know that when it's in a fine granulated form or fine granulated state, it mixes well. I'm going to do the same with salt and I'm going to make sure that there are no particles left behind. I'm going to wait until it settles and after that I'm going to add my ingredient, which is a food color. So you all can add any food color if you all wish to add, and try this experiment at your house. Now you all can see that the solution has been settled. I'm going to add a few drops of food color solution to all the 3 glasses. This glass contains sugar solution, this contains normal water and this contains the salt solution. Let's see what happens. Let's wait a few moments to see what happens. We all can see that the diffusion is taking place. When I add more of food color solution to each of the glasses, let's see what happens then. We can see that in the glass where there is only water, the diffusion has taken place completely. Whereas in the glass which contains salt solution, the food color just remains above with slightly tinged pinkish shade that it leaves below. In the sugar solution, we can see that the food color begins to go down, but then it again settles upwards. Now why is this happening? Phenomenon occurs because as we dissolve salt and sugar in the water, the spaces inside the water, the molecules which have spaces, these intermolecular spaces get filled up by the salt particles or the sugar particles, and hence when I add watercolor or food color into it, there is no diffusion that takes place, because the intermolecular spaces are already being occupied by the salt particles or by the sugar particles. So this is the main principle behind dissolving of food color into different types of solutions, namely salt water, sugar solution and normal water. There must be a question in our minds that what happens if I add too much amount of food color in all the solutions? The answer still remains the same. That is, if I add more drops of food color into the salt solution or sugar solution, it is still going to float. That means it's still going to be on the top layer. Whereas, if I add food color to the normal solution, the only thing that's going to happen is the color of the water is going to darken. Because in the normal water, there are still intermolecular spaces left, and this intermolecular spaces will be taken up by the food color that we are adding into it. The other reason can also be that the salt water is denser than that of pure water. That means that the salt water which is denser is going to settle down, and the pure water, which is the food color, is going to float above, as food color is less denser than the salt water. My next experiment is going to be about blowing a balloon. Now, here I'm not going to physically blow a balloon, but we'll perform a small experiment by which the balloon automatically gets blown and deflated. Now, for here we need a bowl of hot water, a bowl of cold water, 2 empty bottles, one large, one small, and balloons. So first, I'm going to fit these balloons on the mouth of each of the bottles, and then I'm going to pour hot water and cold water accordingly inside the bowls. Let's see what happens. I have capped both the bottles with the balloons, and now I'm going to place the larger bottle inside the hot water bowl, and then I'm going to place in the cold water bowl. Let's see what happens. We see that the balloon has been blown. I have just kept my bottle inside the hot water bowl. Now I'm going to place this bottle in the cold water bowl. We can immediately see that the balloon got deflated. Again, I like to place this bottle in the hot water solution. We'll wait till it blows up. When I place it back again in the cold water solution, it immediately deflates out. Now, I'll similarly do this with a smaller bottle. When I do this, the balloon does get inflate a little bit, as you all can see here. It's getting inflated but only a little bit. Here it gets deflated again. It's completely deflated. Now, why does the air in the balloon, when I put this bottle in the hot water, inflated, and when I put it in the cold water, it got deflated? The principle behind this experiment was that the expansion and the contraction of the air. Now, when I placed an empty bottle which was plugged up with a balloon inside the hot water, the air inside the bottle expanded. And because of that, and as a result of that, the balloon also expanded. Yes, and when I put it in the cold water, the air contracted, as a result of which the balloon also contracted. Now, in the smaller bottle, we did not see the same results as good as the one that we saw in the larger bottle. Now, this is because the larger bottle had more volume of air, whereas the smaller bottle had lesser volume of air. So, the balloon did expand, but it did not expand completely, whereas in the larger bottle, the balloon expanded completely. Now this shows that the volume of air also matters. The bigger the container that you put in a hot water bowl, the more the balloon will get expanded. And similarly, if you put a smaller container in a hot water solution, the balloon will get expanded only till the amount or the volume of air that is there inside of that container. The next video is about the color explosion. Now, for this we require a plate, some tablespoons of milk, food color and a dish soap with cotton plug in it. First, I'm going to pour the milk onto this plate carefully and I'm going to spread it out evenly. Then I'm going to just add few drops of the food color onto the milk. I have different colors. I'm going to add all these colors as I wish to add over here. Now, I am going to place this cotton plug with the dish soap inside of this and let's see what happens. We see the colors are exploding. They are mixed. Now why does this happen? The principle behind this experiment is that when I am adding liquid soap to the milk, the surface tension of milk reduces and the liquid soap reacts with the fat inside of the milk. And when it reacts, it forms swirls of colors. And these swirls of colors occur because I had added food color to the milk solution. Now, this interaction causes the fat particles to move, and because of that we see a colorful design that is being formed when I add the cotton dipped in the liquid soap solution inside of the milk. My next experiment and the last one is going to be about a playful experiment which involves gems, water and a plate. I am going to place gems all around the plate in a circular form and then add water to it, and then we will see what happens to it a few moments later. I have now placed the gems evenly and I'm going to add some water to it and let's see what happens. I'm going to make sure that each of the gem is being dipped inside the water. We wait for a few moments and see what happens. We can see that the blue color gem has already started releasing the color that it had. After a few moments, I can see that all the gems has started diffusing its color into the water that I added. This is a simple phenomenon of diffusion from where the water was at low concentration and the color of the gems was at a higher concentration, and hence the color is being diffused or being given out by the gems from its higher concentration to its lower concentration. I hope you all enjoyed the video. Thank you for watching this video so patiently. I hope this video yields of great help to all of you all, and I hope you all do these experiments at home and give me in comment section below whether you liked it or you did not like it. Follow my YouTube channel EduQuest by Janvi Doshi for more such videos. Have fun!